So y'all, 9.1 is probably something not many people seen a lot. This is called composition of functions. And there's two we're going to look at in this section. First, we're going to look at, some people call this fog, but it's F, and then it looks like a little degree symbol, and then my G of X. So this basically means F of G of X. So what's happening in this situation, the G of X is what I would put into the F of X function. So instead of just putting in a number, we're going to be putting in a whole function for it, okay? So when you got F of G of X, this means, now, if I'm given a number for the X, so if given a number for X, then substitute the number into G of X first, then evaluate it. So then we're going to evaluate the function for G of X, and then put that answer into F of X. So it's like you're doing a two-part function. You figure out the G of X first, get me a single answer out of that. Then we'll put that answer into the F of X equation. Now that's if a number is given for the X. If no number is given for X, then we would put the G of X function into each X for the F function. So if they give me a number, they're not too bad because I can put it into the G, get my answer, put that into the F. Which all, if they don't give me a number for the X, then the only thing I can really do is simplifying it. And to simplify it, I would put my whole G of X equation in for each of the X's of my F. Now, the other way we'll see this would be G compose F of X. Which means on this one, you'll be finding G of F of X. So we won't write all this one out. It's the same thing as doing the F of G of X, except we would start with the F of X, get that answer, and then put that answer into the G of X. So it's almost like if you're looking at order of operations, you would work the innermost function first, and then go into the outermost function. Okay, so remember, these are just the same. G of X is just the opposite of the F of X. So we're going to play with a few examples, and I'll show you what this is all about. But to me, it's probably easier doing it with numbers than it is when they don't give me the numbers. So y'all, my first three examples will have numbers. And then the last three examples, they're just going to give us variables, okay? So for my number one, f of x is going to equal negative 3x minus 1. G of x for us is going to equal x squared minus 2. So on this equation, they want me to find f compose g of a 7. So this, technically, we're going to find f of g of that 7. So remember, we said right here, if given a number for x, we're going to substitute the number into the g of x first. So the first thing we're going to find is g of 7. So g of 7, I'm going to take my g equation, x squared minus 2, and I'm going to put that 7 in for the x. So that'll give us a 7 squared minus 2. Now, we're just going to hit it with a little order of operations. So 7 squared is 49. So I get 49 minus 2, which will give us 47. So first thing we did here, I'm going to write this out. First, put 7 into g of x. Now, since g of 7 equals 47, we're going to take the 47 and put into the f equation. So that means we're going to be finding f of a 47. So right here, we put 47 into the f of x. So f of 47 will equal that negative 3 times 47 minus our 1. All right, y'all, so let me multiply that out. That's going to be what a negative, looks like 141 minus 1. And my negative 141 minus 1 will give me a negative 142. So, guess what? Negative 142 is our final answer. So, y'all, that's the trick on these. These are two-part equations when you got this composition going on. And that's not a 0 or a O. That looks like a little degree symbol almost sitting in there, okay? All right, y'all, question on this one. Now, if this would have been g of f, I'd have put the 7 into the f, got that answer, then I would have put it into the g. So the order matters what they're giving you in the problem, okay? Are y'all ready for another?
I have a question.
Okay.
So when you said if they give you f of g, then you're gonna start with g first, and then if they give you g of f, you're gonna start with f first.
Right.
Okay.
So it's almost like they're working right to left. You take the number, put it into the G, get that answer, put it into the F.
Okay, I got you.
Okay. Ready, awesome. Let's try another one with numbers here. So we're going to be given f of x on this one equals 2x plus 4. G of x is going to equal, oh, let me let one in real quick. All right, then my g of x is going to be x squared minus 3x minus 5. And y'all look here, this time they want me to find g of f of a 7. Also, looks like on my problem, 7 is the lucky number for today. All right, so remember, this is now a g of f of that 7. So remember, this one we're going to put the 7 into the f equation first. Once we get that answer, we'll put it into our g equation. So y'all, the first thing we're going to find is definitely going to be f of 7. So f of 7 will be 2 times 7 plus 4. All right, so y'all, let's work that. That's going to give me what? 2 times 7 is 14 plus my 4. Adding 14 and 4, I get what? 18. So this one, the first thing I did, put 7 into f of x. Now, since f of 7 equals 18, that means we're now going to find g of this 18. So at this point, we're putting our 18 into g of x. All right, so g of x is a little longer here. I got 18 squared minus 3 times 18 minus that 5. And y'all, that's the trick also. When you got more than one x, you got to put that thing into all these x's, okay? Woo, let's see. We got to figure out 18 squared. So I got a calculator that'll help me do that. And so calculator, let's see. 18 squared. Enter. That's going to give us 324. So that's going to give me 324 minus 3 times 18, which is 54, minus our 5. All right, y'all. So let me get my calculator and I'll figure that out real quick and we'll get our final answer. So we got 324 minus 54 minus 5. So y'all hit enter on that. Our final answer looks like 265. And that right there is what Math Lab's going to want. Now, y'all, the reason y'all are learning this kind of stuff is for your science classes. If any of y'all got to take chemistry or physical science or anything like that, sometimes in science, in order to find one of your formulas, you got to work another formula to get one of the variables to put into it, okay? And that's why we teach you all this stuff. All right, so how about one more with numbers, and then we'll do it without numbers. So for my next one, I'm going to do f of x equals 3x plus 4. G of x is going to equal x to the third. We're going to find f compose g of a negative 4. All right, so remember, f compose g of negative 4 will be the f of g of that negative 4. Which means, y'all, the first thing we're going to do is put negative 4 into our g equation. Once we figure out what that equals, then we'll throw that into the f. So G was x cubed. So that's going to give me a -4 to the third power. All right, so 3 negatives will end up negative. And let's see, 4 times 4 is what, 16? 16 times 4 is 64. So a -4 cubed gives me a -64. All right, since G of -4 gave me -64, that means we're now going to find F of that -64. So F was 3x plus 4, so that'll give me 3 times -64 plus 4. So y'all, so let's see, 3 times 64, that looks like what, a -192 plus 4. All right, now I'm going to tell you the truth. They're going to try to mess with y'all with all this adding these like signs and unlike signs and all that fun stuff. So let's see, 192 minus 4 is 188. Larger number is negative, so that's going to stay a -188. So these aren't too bad. You just got to get used to putting them into one function, getting that answer, sticking it into the other function. So if y'all have any questions on those three? Oh, y'all gonna try to make me sleep if y'all yawning. All right, y'all. So now we're not going to get numbers to put into these. So these 3 examples, they're going to increase the problem a little bit here. So check this out. On these problems, they want me to find f of g of x. And g of f of x. And the domain of each. Now I'll say the first 2 that I do won't be too bad, but this number 6 that I got, it's a doozy, okay? All righty, y'all. So f of x equals x plus 17. G of x is going to equal x minus 17. So what we'll do, we'll find f of g first, then we'll do g of f, and then we'll look at the domains of each of these, okay? So y'all, I'm going to start off doing f compose my g of x, which is the same as we said f of g of x. Y'all notice they didn't give me a number this time. So since I didn't get a number for the x, what they want me to do on this problem is put g of x into each x for f of x. So basically what that means is we're finding f, and y'all, g of x is x minus 17. So we're finding f of a x minus 17. So f equation is x plus 17. Where we have an x, we have to put in the g. So we will have a x minus 17, and then bring down our plus 17. So notice I took this whole g of x here and put it into the 1x. So y'all, can you simplify this thing down a little bit? So definitely, and y'all, we got to add these like terms, but guess what? Negative 17 and 17 cancel. So all that's left is our x. All righty. So then they said, hey, find g of f of x. So we'll come down here, g of f of x. Now remember, it'll be opposite. This one will be the g of f of x. So what this one means, since they didn't give me a number again on this one, we're going to put the f of x equation into each x for the g of x. So that means on this one, we're going to be finding a g of x plus 17. So you see on the first one, I put the whole g of x in for that variable. On the second one, g composed f, I'm putting the f equation in for the g. So look, here's g, x minus 17. I'm putting in my x plus 17 for the x, and then I'm going to bring down my minus 17. Oh, and y'all, look what this one's going to give me. Pretty much the same thing. 17, negative 17, they're going to cancel out again. All that's left is my x. So, and the reason this one worked out that way is because one of these was adding 17 and one of these was subtracting 17. All righty. So now I'm going to do the domain of f of g of x. Now, y'all, we're going to go step aside before I do the domain on this one real quick. I'm going to show you another way to do the domain. You remember yesterday we did that set builder notation where we had the x such that x was a real number and blah, blah, blah. Well, today, for these problems, we're going to use what we call interval notation. So interval notation, we use parentheses and brackets, and we represent all real numbers a certain way. So in interval notation, all real numbers. So we start with a parenthesis on the left end point. So y'all, let me ask you this. If you were sitting on the x-axis and you went in the negative direction and you kept going in a negative direction and you kept going in a negative direction, where are you headed off towards? So are y'all familiar with negative infinity? Yeah, negative infinity means
Yes.
I'm going off to the negative direction as far as I can go. Now, what if I was going off in the positive direction? And I kept going and I kept going. I'm headed off towards positive infinity. So when we want to use interval notation to represent all real numbers, we say that we can have any x values from negative infinity to positive infinity. So now, what if I want to kick out a number? So to exclude a number, A, we would use the union symbol. So watch what I do. So if I wanted to exclude an A from my domain would start at negative infinity, go to the number. At that number, I'm going to put a curvy parenthesis around it, do the union, and then on the right side, start from that number again. And then y'all, from this number, I'm headed off towards positive infinity. So
Could you explain that one more time?
So here's the thing. When you're looking at interval notation, if I use brackets, brackets are like doing greater than, equal, or less than equal. If I just use parentheses, that's good for greater than or less than, but it don't include that number. So if I go from negative infinity up to this A, and I want to kick that A out, I'm going to use a curvy parenthesis around it, because that means I'm going from negative infinity almost to the A, but since it's curvy parentheses, it can't equal that A. This little union stands for and. So it goes from negative infinity almost to the A, and on the right side of the A, all the way to positive infinity. So this right here, this parenthesis, union parenthesis, is kicking the actual number out of the interval. Now, if I wanted to include numbers like A, I would use these brackets here, okay? So let me show you an example. So say I was doing one of them fraction problems, and when I set my denominator equal to 0, it came up with a 5. If I want to kick a 5 out of my domain, so here we go, to kick out a 5 from the domain, it would start at negative infinity. Now, y'all, the reason negative infinity and infinity have parentheses is because there's no ending point. I can't put a number there and put a bracket, because infinity is going to keep getting more negative and more negative and more negative. Same thing with the positive infinity. But to kick out this 5, you're going to go from negative infinity to the 5, parentheses. Then you're going to union that, parentheses, from 5 to positive infinity. Now, for every number I kick out, I have to have a union around that number, okay? So, negative infinity to infinity, all real numbers. When you use the union, you're starting to kick out those numbers, okay? And remember, we're really only worried about numbers that make me have fractions with a 0 in the bottom. That's still all we're worried about on these. So let me bring my problem back. So we're going to look at the domain of this f of g of x. And we worked it right here. So let me ask y'all this. Do y'all see any fractions? All we got is an x minus 17 plus 17, and then that worked down to an x. But there's no fractions here, right? So since there's no fractions, what do y'all think my domain will be?
Negative infinity, positive infinity.
Damn, that's it. Remember, only thing I'm worried about still is those fractions. So let's look at the domain of our g of f of x. Well, y'all, g of f of x, we worked right here. We had an x plus 17 minus 17. That thing simplified into an x. So my question is, what's that domain?
A positive infinity to negative.
Oh, you're right. But always go negative to the positive, okay?
Oh, okay.
So good job. Yeah. So always remember these are going to read these from left to right like you would a number line. All right, y'all. So let's see what they got next. Same thing. We're going to find f of g, g of f, and the domain of each. All right, but this time f of x is going to equal x plus 3. G of x is going to equal 2x squared minus 5x minus 3. So first, let's find our f of g of x. And once again, that's just like f of g of x. So that means I'm going to take this g of x and put it all into my f equation. So I'm finding f of a 2x squared minus 5x minus 3. So that means I'm going to take the x in the f and put this in it. So replacing that x with this function, you get 2x squared minus 5x minus 3, and at the end is a plus 3. So the entire g equation went into the f. So can y'all go further on that?
Yes.
All righty, so what y'all doing?
Combine like terms.
And oh, look at that. Those like terms sort of cancel out and they're gone, right? So I get what? My 2x squared minus 5x. All right, y'all, no more like terms, so we cannot go any further. So that means next, we're going to find g of f of x. So that'll be g of f of x. So that means this time we will take the f equation, x plus 3, and put it in for each of the x's in the g. So we're going to be finding g of x plus 3. Okay, so that's what I was talking about. Function goes into the x's. This function's going into the g's x's. And y'all, the g has 2 different x's, so let's play with that. We're going to have 2 times x plus 3 squared minus 5 times x plus 3 minus 3. So when you do the g of f, it looks like the g equation, except you got some big x's here. When we did the f of g, it looks like the f equation with a really big x on it, okay? Y'all know what? First thing you got to do to this is add exponent. Now, x plus 3 squared does not equal x squared plus 9. X plus 3 squared, I'm going to work that on the side right here. Y'all, when you got an x plus 3 squared, you got to write x plus 3 2 times. This is a FOIL problem in disguise. So you got to figure out what the x plus 3 times x plus 3 is. So you're going to do the x times the x. You're going to get an x squared x times 3 gives me a 3x. Inside, 3 times x is 3x. And then the last, 3 times 3 is 9. I'm going to add like terms so that I get an x squared plus 6x plus 9. All I did on that step was figured out that x plus 3 squared. So let me bring that down. I'm going to now have 2 times what I just figured out, x squared plus 6x plus 9. And then everything else I'm bringing down. Negative 5 times x plus 3 minus 3. So remember, we're working on PEMDAS here. Please excuse my dear Aunt Sally. Nothing I could do inside the parentheses. So the next thing I had to do was my exponent. All right, just remember, when you got a binomial like this being squared, write it twice in FOIL. Now I'm going to get rid of these parentheses by doing some distributing. I'm going to distribute this 2 through those first parentheses. So 2 times x squared gives you a 2x squared. 2 times 6x gives you a 12x. 2 times 9 gives me 18. Now the second parentheses, I'm going to distribute a negative 5. Remember, since the 5's negative, you got to distribute that negative. So negative 5 times x is a negative 5x. Negative 5 times 3 is a negative 15. And then y'all at the very end, bring down that negative 3.
This one has a lot of steps to it.
Yeah, and what was getting us was because that g of x was a 2x squared minus 5x minus 3. So it gave us a lot more terms on it, okay? But we're doing the hard part. Guess what? All I'm going to do now, add those like terms. So look, this 2x squared is coming down. Let's see how many x's I got. I got 12 x's minus 5 x's. So let's see, 12 minus 5 is giving me 7 x's. So that takes care of all the x's. So let's see what this number gives me. 18 minus 15, well, that's 3. And that 3 minus 3 is gone. So the numbers all cancel out. So the final thing is our 2x squared plus 7x. Yeah, I'm not gonna lie, these ones are a little tricky. And probably because of this part right here where we had to actually FOIL it out and get that trinomial, okay? All right, y'all, domain f composed g of x. So here was my f of g of x. 2x squared minus 5x minus 3 plus a 3. We worked it out. My question is, what's that domain?
Negative infinity and positive infinity.
Good. Y'all say that every time y'all don't see no fractions, all right? All right, then y'all can also give me my g of f of x domain. So that was all this down here where we had to FOIL and do all that fun stuff. So what's that domain?
The same.
The same. There you go. Now, y'all, I ain't gonna lie to you. My next one, we will have to do a little more work on the domain, okay? All right, so I'm gonna let y'all catch up on the writing real quick, and then we'll knock out the last one for this section. But y'all, this is why you're taking my class, right? Because y'all love doing these nice algebra problems.
I mean, I don't know about loving it, but gotta take it.
I'm praying I pass.
Mhm. Now, my test ain't really as crazy as some of these problems, okay? All righty, y'all. So let's do the last one for this section. So the same thing, but y'all look at this. So let me see what my chat's saying here. Oh, that must be about my math comment, huh? Y'all liking it? All right, y'all, but watch here. I got f of x equals 2 divided by 1 minus 9x. G of x is going to equal 1 over x. So if you notice now, I definitely have fractions. So my domains probably aren't going to be that negative infinity to infinity when we hit that part, okay? So let's start off doing the first thing they wanted, f of g of x. So that's f of g of x. So remember, that means I'm going to take this g of x, which is 1 over x, and I'm going to put it into the x on the f equation. So that means we're finding f of a 1 over x. So take your f equation, which is 2, divide that by 1 minus 9. And y'all remember, in place of that x, I'm now putting a 1 over x. So check this out. The first spot you got to look at when you're doing the domain is you got a fraction here with an x in the bottom. What can that x not equal?
Zero.
0.
There you go. So at that point, we know there's one number we're going to kick out for sure later, and that's got to be 0 because of this. Now, y'all, here's the thing about this problem is we're going to have to try to simplify this thing. So the first thing I'm going to do, I'm going to put a 1 under the 9, and I'm going to multiply the 9 times 1 over x by multiplying straight across. So the top will stay at 2. The bottom will be 1 minus, well, the top, 9 times 1 is 9. The bottom, you got 1 times x, which is x. So yeah, that's why this was last. It's a tricky little problem to simplify. Now, we can't leave an answer where you got like a fraction inside of a fraction. This is called a complex fraction. So we're going to have to simplify this fraction. So y'all, what I'm going to do to this, I'm going to multiply all parts by that denominator, which is an x. Now, you got to do that on top and the bottom. So I'm going to multiply x times my 2 on top, x times the 1, minus my x times 9 over x. Now, y'all check this out. The whole reason I did that was because of these x's right here. What can we do to that? Well,
Cancel them out.
I'm definitely going to cancel them out. Good job. So let's see what that leaves me. X times 2 is a 2x on top. X times 1 is the x minus your 9. So now this looks like a normal fraction. I got a numerator and a denominator. So now I'm simplified as far as I can go. But y'all, the reason I had to go further here was because I had a little fraction inside of a big fraction, and that's called a complex fraction, and they don't like those, okay? So when we do the domain, remember this. At this point, x couldn't be 0. What about this point? What can x not be?
0.
0.
Positive 9.
There you go. It can't be a 9 because that 9 minus 9 would make that a 0. So we know right there's the two numbers we're going to be kicking out in a little bit, okay? So now let's try the g of f of x. That's going to be a g of f of x. So this time we're going to take this f equation and put into our x for the g. So that means we're finding g of a 2 over 1 minus 9x. And remember, reason I'm doing this is because I'm just putting in these parentheses what we're substituting into our problem, okay? All right, so g is 1 over x, so that's going to be 1 over, but remember, x is now 2 over 1 minus 9x. So y'all, when we do the domain, we're going to have to figure out this x value, because there might be an x that I can put in right here that might make this undefined, okay? Now, let me tell you this. On this one, I'm going to work it a little different than I did this one. On this one, I got a 1 on top. And then I got my division, and I'm dividing that by 2 over 1 minus 9x. So do y'all remember the rule for dividing fractions? So let me refresh y'all. I'm going to bring down my 1. I'm going to turn my division into multiplication. And if I turn that into multiplication, what am I doing to that fraction?
Multiply.
But first you got to
Change it, like flip it or something.
flip it. There you go. So remember, when we divide fractions, we change the multiplication and we flip the second fraction. So I get 1 minus 9x over 2. Well, y'all, that's nice. 1 times anything is the anything. So I get a 1 minus 9x over 2 as our final answer.
I don't like this problem.
No, and you won't see this one on the test, thank God, okay? But I'm going to tell y'all, the only thing they're going to change on y'all is going to be these 2s and 9s probably. So just sort of follow like we did it on mine. Yours will be exactly the same other than a couple numbers, okay? All right, y'all, I'm going to do the domain of our f of g. F of g was right here. The first number y'all told me this x could not equal was what?
9.
Oh, we did that down here. So x can't equal 9 down here. But that single x, remember, we said that x couldn't equal
0.
0. There you go. So notice you got 0 and 9 we got to kick out of our domain. Now here's the thing. The domain has to go in order from left to right. So we're going to start at negative infinity still. So from negative infinity, what are we hitting first? We're going to hit the 0 first. So we're going to union around the 0. From the 0, we're heading off until we hit that 9. So we're going to go to 9. We're going to union around the 9. And y'all, for 9, I'm headed off to where?
Positive infinity.
Positive infinity. So notice, since I had 2 numbers I had to get rid of, I had to have 2 numbers in my domain. All right, y'all, then we got the domain of the g of f of x. So what we got to do is figure out what this x value is going to give us so that we can exclude that number. And if you notice, there's no more fractions that have a denominator with a variable in it. All that's in this denominator here is a 2. So we don't have to worry about that. But what we got to worry about is this one. So we're going to set 1 minus 9x equal to 0. And let's solve that for the x. So I think yesterday when I had one of these, y'all wanted me to subtract a number first. So that gives me negative 9x equals negative 1. And then divide both sides by negative 9. So now I get x is, remember those negatives will make that positive. So I'm getting an x equals a 1 over 9. Which means if you put a 1 over 9 right here, the 9's cancel. 1 minus 1 makes that 0, which makes it undefined. So for this domain, we're going to start at negative infinity until we hit our 1/9. We're going to union around our 1/9 until we hit positive infinity. So y'all use this as a guide because your g of x will be exactly the same. And like I said, the only thing they're going to change on the f is either that 2 or that 9. And y'all are going to work out really similar. On the first part, you should get 2 numbers to exclude. And on this g of f part, you're only going to get 1 number to exclude, okay? So y'all, you gotta love mathematics, right? All righty, y'all. So what we're gonna do, let's do our little break. 10:53. So let's take a break till at 11. And then at 11, we'll come knock out. Next section is not as bad, okay? Okay, so 9.2 deals with inverse functions. So the first thing we'll look at is finding the inverse of a relation. And once we play with the relation, we'll get that into the functions, okay? So the first thing is finding the inverse of a relation. And by relation, they're talking about like a set of ordered pairs. So if I had a set of ordered pairs, such as A, B, C, D, E, F. This is what they're calling the relations. So to find that inverse of the relations, we simply switch each X and Y value of the ordered pairs. Which means my inverse relation would be BA, which is the opposite of AB, DC, and FE. So the inverses is like the opposites. So all I did, I just switched my X and Y coordinates around, and that gave me my inverse relation. So let's play with that on an example. We want to find the inverse. Of the relation. So y'all, they're giving us -9, 2, 6, -6, -5, 9, and 5, -5. So our inverse. So y'all, anyone want to guess what my inverse relations will be?
2, -9, -6, and 6, and then 9, -5, and then, oh, hold on, I just lost train of thought.
Oh, you're perfect all up to that last one.
-5 and 5.
-5 and 5. Good job. You know, that's all you're doing on these is switching stuff around and being happy. All right, let me see. So this next equation, they want us to find an equation of the inverse relation. Now, look what they're giving me. They're giving me an x to the third y equals -3. So y'all thinking about what I just did up here, my inverse, all I'm going to do is switch that x and y around. So let's see, that makes my inverse a y to the third x equals or -3. So remember, all we're doing here, switch the x and the y. So y'all, that's your first two problems. Just going to have you, they just want you to realize that to find those inverses, we're just switching the x's and y's around, okay? So now, we're going to start talking about functions. But for a function to have an inverse, it's got to be what we call one-to-one. What one-to-one means is each x only has one y value and each y value only has one x value. So each x has only one y value. Each y only has one x value. Almost like my functions. Remember my functions, I did that vertical line test. Well, to check if something's one-to-one, we use the horizontal line test. To determine if 1, 2, 1. Okay, so inverse functions are a little tricky. It does have to be one-to-one. So to check and see if something's one-to-one, we're using the horizontal line test. And what that says that if a horizontal line, can intersect a graph more than once, the graph is not one-to-one. You know, that makes sense. If my graph is getting intersected twice, that means my X value's got two different Y values, or my Y value has two different X's, okay? So I'm going to draw some graphs and we're going to determine whether these are one-to-one. All right, y'all, so let me push this back up. All right, so for these next few examples, we're going to determine if one-to-one using the horizontal line test. So y'all remember, vertical line test is to check if something's a function. A horizontal line test checks to see if it's one-to-one. So y'all let me draw this first one here. Well, there's my X and my Y. So say I have a line coming along, going uphill slowly. So notice, I want to know if this thing is one-to-one. So what I would do is I would run me a horizontal line across this. So let's see, if I run a horizontal line, intersects it once, intersects it once, intersects it once, intersects it once. So since my horizontal line intersects my graph at a maximum one time everywhere, this is going to be a yes. So y'all let me try one with y'all. All right, so this one's on y'all. So what if I got an upside down parabola? Is that graph one-to-one?
No.
No.
Good job, y'all, because any of these vertical lines are going to hit it twice, which means these Y values are getting more than one X. So that definitely is a no. All right, and I'll do one more of these. These aren't too bad. Oh, so let's say I had one of these cube graphs. The cube comes up, sort of goes through the center, and then goes up. Is that graph one-to-one?
Yes.
Okay, good job, y'all. Because if you shoot me some horizontal lines, it's just going to intersect that thing once. Okay, so here's the thing. We're now going to find inverses of a function, and they got a little bit more work to do, but it's not bad. So let me show you what we're going to do. Let me push up. So this is finding the inverse of a function. So the function has to be one-to-one. So if that function's one-to-one, the first thing I'm going to do, I'm going to replace the f of x with y. Because remember, f and x and y are the same thing. It's just symbolism, okay? So I'm going to replace the f of x with a y. Now, do y'all remember earlier when I was doing them ordered pairs? What did I do with them x's and y's? I switched them. So what we're going to do here, we're going to switch the x and the y. So instead of y equals something, I'll now have x equals something. Y'all, once I switch to x and y, I'm then going to solve for the y. Once I solve for that new y, I'll have my answer. In my last step, I'm going to replace that y with f negative 1 of x. This is what we call inverse notation. This is inverse notation. And we don't do nothing with that negative 1. It's not an exponent or nothing. This just represents the inverse function, okay? Now, y'all, here's the thing on this. On these homework problems, they start around number 7 on your homework. Every one of y'all's problems is going to be 1-to-1. So if you put no, the function is not 1-to-1, it definitely going to be missed on this point, okay? These last 5 or 6 problems starting at 7 are all 1-to-1. So these are saying determine if 1-to-1 and then find the inverse. All right, y'all. So my first one, I'm going to have f of x equals x minus 6. Now, if you were to graph that x minus 6 in your calculator, you would see that it would be a straight line. That thing would be a straight line, which means no matter how many horizontal lines I draw on it, it's definitely going to be 1-to-1. So that means we got to find the inverse. So y'all notice my first step. I'm going to replace the f of x with a y. So I'm going to replace this f of x and make that a y. So I now have y equals x minus 6. Step number 2, we said switch the x and y around. So I'm going to switch to x and y. So that's going to give me x equals y minus 6. So if I was putting steps here, the first thing, I replace the f of x with a y. Right here, I switch the x and y. You know, at this point, we need to start solving for that y. So y'all got one move to get my y by itself. What y'all doing?
Adding 6 to both sides.
Definitely going to add 6 to both sides. So notice I now get an x plus 6 equals my y. Now remember, x plus 6 equals y is the same thing as y equals x plus 6. So y'all, it's solved for the y. So my last step is to replace that y with their inverse notation. So I get a f negative 1 of x equals x plus 6. Now, MathLab will give you the f negative 1 of x. All you got to do is put in the x plus 6. Then y'all notice this. Remember, inverses are like opposites. If the main function was subtracting 6, look at my inverse. It was adding 6. You'll see that the function and the inverse function often have moves that undo or the opposite of those operations, okay?
When you added 6, why was it x plus 6 instead of 6x?
Oh, because remember, when you got 6x, that's implying that you're multiplying that 6 times the x. Okay? Now, when you add 6 and x, they're not like terms, so we can't combine them at all.
Okay.
So you just gotta watch out on adding and subtracting. It's really, really picky about whether things look the same or not, okay? Alrighty, y'all. So let's try another one of these. What if I had f of x equals 8 over x plus 1? All right, so I'm going to do the same thing. If you use a graph this, you would see that it is 1 to 1. So that means I'm going to replace the f of x with a y. All right, then we said, hey, we're going to switch that x and y around so that we get x equals 8 over y plus 1. So replace f of x with a y first. Switch x and y. Now, y'all, we got to solve this for the y. So I'm going to show you what I do. If you treat the x like a fraction by sort of putting a 1 under it, to undo this, we would do what we call cross multiplying. So to cross multiply, you would take that x times that y plus 1. That's going to equal your y plus 1 times the 8 over y plus 1. So when you got a variable and a fraction, the way you get rid of the fraction is multiply both sides by that denominator. Because y'all, what are you doing right here? That stuff cancels out on that side. So at the moment, I got an x times a y plus 1 is going to equal that 8. Now, here's something. Usually when you see this, you want to distribute stuff, but don't do that on this one because we want to solve this for the y. So y'all think about this. Since this x is being multiplied by the parentheses, we want to get rid of this x on this side by dividing both sides by the x. So watch what happens. I'm going to divide both sides by that x. So now I can cancel these x's out. And notice what's left. Y plus 1 equals my 8 divided by x. Now, y'all, let me show you what's fun about these. If you realize what I just did, up here, you had an x and then the y plus 1. Down here, I got the y plus 1 equals the 8 over x. All we did in the long run was flip-flop those. So y'all, my last question to y'all is, I got a y plus 1 here. I need that to be a y. What are y'all doing?
-1.
-1, that sounds good to me. I want to subtract 1 from both sides. So that leaves me my y. And y'all, that's an 8 over x minus 1. Those are not like terms. So I'm just going to leave that as an 8 divided by x. minus 1. All right, y'all didn't remember my last step. Turn that y into the f inverse of x. And that's going to equal to 8 over x minus 1. So all you put in MathLab is that 8 over x minus 1, okay? So that is probably trickier than what I got left. All right, y'all ready to move on?
Could you leave it for just a second?
Okay. Yeah, because I want y'all to get all this wrote down before I do my next one, okay? Y'all, these ain't too bad. It's just they're probably new stuff because I don't remember doing these when I was in high school and stuff like this. So this sort of like a new concept.
Okay, thank you.
Alrighty. All right, y'all, we got f of x on this one is going to equal x to the third minus 4. So if you was to graph this, you would see that it would be one of them little curvy lines, definitely 1 to 1. So we will find the inverse. So we're going to replace the f of x with a y. Next, we're going to switch that x and y. Y'all, we're going to solve this for the y now. So, since I got a y cubed there, my first goal would be to get that y cubed all by itself. And the way I'm going to get the y cubed by itself, so right here, we're going to get the y cubed by itself. So they got a -4, we're going to add 4 to both sides. So y'all notice what that does. That gives me x plus 4 over here equal to my y to the third. Them 4's cancel. So let me ask y'all something. Do y'all remember how I can take a y to the cubed and turn that into a y?
Divided by y squared.
Oh, but what would happen if you did this side but y squared? Then you would end up with y squareds on this side. So then my y's wouldn't really be getting isolated for me to solve them. So what undoes exponents?
Division.
Well,
It's y times y times y.
so that's what that means. So y'all, let me show you how I would get rid of a y cubed and turn it into a y. I would take a cube root of that y to the third. Because remember, square roots and cube roots, they find the number that was multiplied times itself. So like this cube root would be finding what variable times itself 3 times would give me y to the cube. Well, what happens when you take a cube root of a y cubed, that cube root cancels with that exponent, and all that's left is your y. Now, since I took a cube root of that side, I'm going to have to come over here and take a cube root of the x plus 4. So this side cubes cancel, giving me a y. But y'all, can I do anything to this side? No, so that side's going to stay a cube root x plus 4. So y'all remember this. To undo exponents, we use radicals or square roots, cube roots, and all that fun stuff, okay? And then remember my last step, replace that y with my f negative 1 of x, and that'll equal a cube root of x plus 4. Now, when you do this answer in Math Lab, it'll have a little radical sitting there with a box. You click this one, that way you can put your 3 in and then arrow underneath and put your x plus 4, okay? All righty, moving on, y'all. We now have f of x equals 2x squared plus 3. And then they got a comma. X has to be greater than or equal to 0. Now, y'all, let me tell you the reason they're doing this. X has to be greater than or equal to 0. So if you were to graph it, you would see that this graph is up here like this. But remember, x squared graphs make a parabola, right? Well, guess what? If you did a horizontal line test, that thing's going to fail it, right? Which means it's not 1-to-1. But let me show you what they're doing with this x greater than 0. When they say x has to be greater than or equal to 0, they're only looking at one side of the graph. So they're restricting my domain so that this thing is 1-to-1, okay? So they're not even looking at this left side. All they're looking at is the right side. So that's why they had to put this here. Because if they didn't put that domain restriction, it wouldn't be 1-to-1, okay? So now that we know the part we're looking at is 1-to-1, we're going to find the inverse. So replace the f of x with a y. And y'all, let me tell you this on this one, they gave me this much of the answer. So they're saying that the answer is going to be something on top divided by 2. All we got to do is figure out what's going on top of this answer, okay? So they're giving me most of my answer, not all of it. All right, y'all. So I replaced f of x with a y. So now we're going to switch that x and y around. You're going to have x equals 2y squared plus 3. All right, y'all, since this is the y squared, I need to get that y squared by itself first off the bat. So we're going to move that 3 by subtracting a 3. Y'all look at that. That's going to give us x minus 3 over here. That's going to equal 2y squared. All right, y'all. The y squared term by itself, but I now need that to be a 1y squared. So to turn a 2 into a 1, we're going to divide both sides by the 2. So those 2's cancel. I get x minus 3 over 2 equals my y squared. So y'all, my final question to y'all. How can I turn this y squared into a y?
Square root.
Square root. Good job. I'm going to do square root of the x minus 3 over 2 equals square root of my y squared. And y'all notice the right side, that's nice. That's going to give me my y. Can you do anything with this on the left side? No, so that's just going to stay square root of x minus 3 over 2. And if you notice on their answer, They got the 2 on bottom like we got. All we had to do was come in and put that x minus 3 and be done. So they're not too bad once you learn how to get rid of these cubes and these squares and all that fun stuff, okay? And y'all, guess what? We got one more to go, so let me let y'all catch up on that writing. Because I definitely wanted to go through all these examples for y'all that y'all are going to see, okay? All right, y'all, so last one. Is going to be f of x equals the square root x plus 4. Now, if you was to graph that, you would see that it would be a slow uphill curve to the right, but it's still going to be 1 to 1. So we got to find the inverse. So y'all, the first thing you're going to do, replace the f of x with a y. Then we're going to switch that x and y around. Oh, look at this, y'all. I'm solving this for the y, but it's stuck under a radical. I cannot move that 4 at the moment because it's stuck under that radical. So here's my question to y'all. How can I get rid of that square root radical?
Square it.
Square it. Good job. So exponents undo radicals, radicals undo exponents. Good job. So I'm going to square both sides. So I'm going to get an x squared equals my square root of y plus 4 squared. Well, y'all, once again, that exponent cancels that radical. So I get an x squared equals my y plus 4. Oh, now that y plus 4 is not under a radical. So what's my last step? And we're done.
Subtract both sides.
There you go. So I'm going to subtract both sides. And let's see, I'll get what, an x squared minus 4 equal to my y. And then y'all remember, they're going to put it in inverse notation form. And actually, I think on this one, on their answers, they got an A, B, C, D. On this one, it has the x squared minus 4, and then it still tells you that x has to be greater than or equal to 0 on this one, okay? Reason x has to be greater than 0 on this one, because if you know about radicals, you can't take square roots of negative numbers because it makes those imaginary numbers and all that fun stuff. So, but yeah, that's it right there, y'all. So x squared minus 4. So questions on that. They're probably a little better than doing that composition stuff. I ain't gonna lie, the compositions can be tricky. All righty, y'all. So everybody got this written? All right, so I'm gonna stop my share then. All righty, so I know I had some questions. Let me see. Let me pull my chat up real quick. And let me see what numbers these were. 11, 12, 13, 15. Michelle, do you remember what section those were from? Was it the stuff I did yesterday?
2.4.
2.4. Okay. All right, y'all. So I'm just going to go to 2.4 and look at some of these questions real quick. I'm gonna have to pull up my math lab real quick. All right, we're gonna start with 11. All righty, so let me get back on my screen here. So y'all, I'm mainly just going over sort of like support stuff now. I had a student wanting to know about 4 questions from yesterday on 2.4. So if you're good on all your homework up to now, I will see y'all tomorrow for our last section of the week. Anyone else wants to stay around and watch us do some of these problems that was in our support and from 2.4 yesterday, these were some that we didn't actually do in the class. I'm going to do these examples real quick. So I'm going to share my screen for 2.4 so we can see what that problem is.
So this is the support part now?
No, this was actually the 2.4 algebra functions. But some of these problems, I didn't do all of them in the class. And some of them are sort of tricky, so I'm just going to go over some of those. Now, here's what I'm going to do. I'm going to start sending out support videos with my college algebra videos for y'all. And the support videos will go through the problems like you're going to see on those. Okay. So let's see what we got on this number 11. It's got f of x equals x squared minus 18. G of x. Oh, I got a screen in my way. Let me see if I can move this thing. What's that? G of x is 19 minus x. They want me to find f minus g of a -4. All right, so I'm gonna go to my pad and we're gonna work this real quick. And Michelle, what they're doing on this, I would start out my f minus g of -4 is going to equal my f equation minus my g equation. And then I'm going to put a -4 in for these x's. Now, where they're going to get y'all at is this x squared. So when you put your -4 in there, put that thing in parentheses, minus the 18. And then we'll put a -4 over here. So that'll give me 19 minus -4. I'm going to work each of these parentheses. My last step will be subtraction. So remember this, any number you square ends up positive, okay? Now the calculator, if you just punch -4 and square it, it'll give you -16. You got to put that -4 in parentheses because the calculator has to know whether you're squaring that negative or not, okay? So watch this. -4 squared is 16 minus my 18 minus over here. So what's happening here? 19 minus a -4. Yeah, that's going to be like a big plus sign there. So 19 plus 4 gives me 23. So y'all, I'm just going to figure out what 16 minus 18 is, drop all these parentheses, and we'll get an answer. So 16 minus 18 give you a -2 minus your 23. 2 negatives, add them up and get what, a -25. So y'all, that's the trick on number 11. Watch out for squaring those negative numbers, okay? All right, Michelle, let's go get your number 12 here. All right, so number 12, let me arrow down one. Oh, now this one was sort of tricky. F of x equals x squared minus 14. G of x equals 19 minus x. But look what they want. They want f times g of a small k. So let me see. F times g of k is going to equal my f times my g. But now remember, for f, I'm not putting in an x squared minus 14. What am I putting in here? I think I heard y'all say k. Okay, so that's definitely, we're going to put a k squared minus 14. So the k is what they want me to put in for my x's this time. And then over here, I'm going to have 19 minus my k.
You can't see your screen.
Oh, y'all know what? I didn't share that screen, did I? All right, so I'm putting the k in for my x's. So I got a k squared minus 14. And then my g was 19 minus x. So we made that a 19 minus k. And y'all, this is one of them fun ones where you get to FOIL. And remember, on these, most of this multiplication is going to be some kind of FOILing for y'all. So to FOIL it, my first one's k squared times 19 is a 19 k squared. K squared times negative k is a negative k to the third. Remember, I'm adding exponents on that multiplying. 2 plus 1 gave me 3. All right, y'all, to enter. Woo, negative 14 times 19. I have to calculate that real quick. Let me see what I get on my calculator. What did I say? Negative 14 times 19. It's negative 266. So that gives me a negative 266. And then that negative 14 times negative k gives me a positive 14k. Now, y'all, although this one didn't have like terms, they wanted it in descending order. So we got to put the highest exponent first, which is the negative k3. The next exponent would be the k squared, so that's a positive 19k squared. Then I would put the 14k. Then I would come down and put my negative 266. So watch out when they say they want descending order. They want you to go from the highest exponent down to that number, okay? All right, so let me let y'all get that real quick. It's not too bad. You just gotta get used to their lingo they use. And watch out for what they're wanting to put in for those variables, okay? All righty, y'all. So let me go to 13 while y'all are writing that. All right, also, y'all seeing 13, it's division, it looks like. So f of x for this one is going to be x squared minus 3. G of x is going to be 20 minus x. They want me to find f divided by g of a 15.
Switch your screen.
Yeah, I was just writing down that problem.
Okay.
All righty, so here we go. So y'all remember this. F divided by g of 15 will equal my f equation on top divided by my g equation. So on top, I'm gonna put that 15 in for the X. On bottom, I'm gonna put 15 in for that X. So I'm gonna work the top, work the bottom, and my last step will be a little bit of dividing there, okay? So woo, 15 squared, 15 by 15, I think is what, 225? So I'm gonna get 225 minus 3. And y'all, let me check my math real quick on that. 15 and squared. So yeah, 225. All right, on the bottom, 20 minus 15 is 5. And I can actually go further on top. So let's see, 225 minus 3 gives me what, a 222 over 5. So y'all, the only thing I would do now is maybe try to reduce that. Can we reduce that 222 over 5?
You'd get a decimal.
Well, we don't want that. And I don't want no mixed numbers. So since 222 and 5, well, the only factor you're going to divide 5 by is a 5. But y'all, 222 don't divide by 5. So that thing does not reduce. And I'll show you what I would do on my calculator to check that. On my calculator, I would do 222 divided by 5. Now watch, when you do that, you're going to get a decimal. But if you hit math and enter twice, look what it does. It turns it back into 222 over 5, which means it does not reduce. Okay. All righty. What was my other one? I couldn't remember. 15. So let's see what that 15 got. I think that was a tricky one too. Let me pull it up.
I just had a quick question.
I hear you.
So for the calculator, which type did you say? Could I use a TI-84 or no?
Oh, that'd be perfect.
Okay, thank you so much.
Yeah. So everything I'm doing, you'll be able to do on that 84, okay? Oh, okay. So this one was one of those where we had to do the domain stuff of the sum, difference, and product. I could have swore I thought I did one like this one. So let me write my problem down real quick. All right, y'all. So let me go on my screen. So they wanted me to find the domain of the sum, difference, and product. So the sum would be f plus g of x. That's going to equal this f, which is 1 over x minus 2, plus my g, which is 6x to the third. So let me ask y'all anything about this one. Do I have any restrictions on this domain? Well, y'all, the only thing we've been worried about on domains is these fractions, right? And we do have a fraction. It's possible there's a number that can make this equal 0 in the bottom. So y'all, what number would make that equal 0?
+2.
Positive 2. So since a 2 makes this 0, which makes that undefined, I can't add undefined plus anything else. So we got to kick the 2 out of our domain. So it's going to be x such that x is a real number. And x cannot equal a positive 2. Now remember, y'all know a new way to write this. So the new way, I'm going to get y'all good at doing that interval notation. If I was doing interval notation, I would go from what? Negative infinity until I hit 2. Union around to 2 until I hit positive infinity. So these are both telling us the same thing, except this is a lot less writing than this stuff is, okay? All right, y'all, subtraction would be 1 over x minus 2 minus 6x to the third. So y'all, any guesses on that domain?
X is a real number and X cannot equal to 2.
Exactly, because I got the same fraction sitting here. If I put a 2 into that, it's going to make it undefined. And you remember we said yesterday that these two are always going to have the same domains. So x is a real number. And x cannot equal a 2. All right, y'all. And then finally, they said, hey, we want the product f times g of x, which will equal 1 over x minus 2 times my 6x to the third. All right, y'all. So my last one, what are y'all doing with this domain? Well, sort of like the same situation, ain't it? I'm still worried about this fraction. And the only thing that x cannot equal is a 2. That makes this whole thing undefined. So x such that x is a real number. And our x cannot equal a positive 2. Yeah, and Michelle, you'll notice on these that usually you're adding, subtracting, multiplying. They're always going to have the same domain. So if you can figure out that first one on these, then you can sort of play with them and get those domains. Only one that'll be different is division. And that's why I think it was the very last problem where you only had to do that division, okay? So that's what was happening on those problems. You know, that's why I like doing my support. It sort of gets y'all fixed up on some of these problems you got issues with, okay? Now, like I said, today, I'm going to start sending out support videos for every support that you have that's going to be going along with these homeworks that we're doing for each day, okay? Some of them had you doing like terms and all that fun stuff. Some were trying to reinforce more of your graphing and all that. Oh, I can't hear you. I know I'm seeing Michelle talk, but I can't hear it.
Oh, I wasn't saying anything yet.
Oh, okay. Your thing was lighting up like it was.
Well, background noise. So
Okay.
are you doing your support class today?
Well, that's sort of what we're doing now. So
Okay.
it just depends on y'all.
Well, if you're gonna send those support videos for all the different ones we've had so
Yeah.
far, then I might just try to do it with that.
Yeah, do that. And then what we do, I leave my computer on. I'm going to shut it down so I can get my video sent out. But I
Okay.
turn back on my web Zoom link. So if you do see something within the next hour or so that's bugging you, jump back on it. I had a young lady yesterday. I can't remember which one of y'all, but she got on here and we went through about 6 or 7 of her problems, got her fixed, and that's what it's for. So if you need me, jump back on here. I'll see that you're on there and we can fix anything. But yeah, like I said, to give y'all extra help, I'm going to actually send those support videos.
Okay, I have an errand or so to run, and then I'll see what's going on after that.
Okay, that sounds good.
All right, I'll see you later.
All right, everybody. So I'll see y'all tomorrow. Remember, if you got to need me the next hour, jump back on, okay?
All right, see
Thank
ya.
you.
Bye.
All right, y'all have a good day.
Bye.
Bye.
Bye.